Hi there. Let me take a few minutes to talk through question 15.2 and in particular the parts of this table that are important. So here's a class of students where they took the lengths of their arm spans and their heights and they ran a linear regression to try and estimate the relationship between the two. So in part A of the question, your job is just to write the equation of that regression line. So what you need to write the equation includes the constant or the y-intercept. So here is its value of 11.547. So you'll also need the slope. Remember, the slope is multiplied to the explanatory variable. The explanatory variable is arm span. So here is the coefficient for arm span, or is its slope, 0.84042. You will not be doing any inference on the constant, so we don't have to worry about the standard deviation, the t-ratio, or the p-value for the constant. However, we will eventually for slope. So this is the standard deviation or the standard error for the slope. You don't need it to write the equation, but it's something I would want you to be able to read out of the table. Again, here's the t-ratio that eventually I would want you to read out of the table, and the p-value. These would be used in doing a hypothesis test for the slope. That's something we'll do in just a little bit. Down here in the table, S represents the sample standard deviation of the residuals. It's used to calculate the standard error here for the slope. You won't normally have to calculate this yourself, so you won't normally have to use this in a calculation, but it's important to recognize. So here's the value of r squared. That's something you want to be able to identify and be able to interpret. We won't be using adjusted r squared. So in order to write the equation then of the regression line, here's what I wrote. Make sure you use y hat. That's the predicted height or the predicted y value. Here is the constant, 11.547. Here is the slope, the 0.84042, times x, the explanatory variable. When you write an equation, make sure you define both x and y. So x is the explanatory variable, arm span in inches, and the response variable is y, the height, in inches. So the other part of the question asks, is this model appropriate? And if it is, would it be reasonable to predict a student's height from an arm span of 76 inches? So first of all, yes, this model is appropriate for two reasons. The residual plot shows no pattern. So let's take a second and go look at the residual plot. Here it is. The residual plot plots, if you will, the errors that this model is making in prediction. Notice, because there's no pattern, that tells me that the model isn't consistently making the same mistake over and over again. So this is one reason why we believe that this linear regression model is a good fit. The other reason involves the value of r squared. Notice r squared is 87.1%. You need to be able to interpret r squared in context. So here are the parts. This means that 87.1% of the variation in height is explained by the linear regression on arm span. So the things you need to include are the percent. You need to include the fact that you realize that's a percent of the variability in the response variable height. You need to say that it's explained by the linear regression, but the linear regression using what input? The linear regression using this input, this explanatory variable, arm span. It really is important to be able to interpret r squared in context. So because the model is a good fit, yes, predicting a student's height from an arm span of 76 would be a reasonable thing to do. Understand, if the model weren't a good fit, we wouldn't want to use it for prediction. So it's important to say, yes, this model is a good fit, so we can proceed. And then lastly, a vocabulary word to remember. It's okay to make a prediction with 76 because 76 fits within the interval of the data used to make the model. If it didn't fit within that interval, say an arm span as high as maybe 85 inches, we wouldn't want to predict a height from an arm span that large because that would be extrapolation. That would be a value of the explanatory variable above the ones used to build the model. And I'm not sure that the model is appropriate for those. So again, here's how I know. If you look at the residual plot, here's 76. So 76 is in the interval of the residuals that are plotted. So the lowest value, the lowest arm span used was somewhere below 64. The highest arm span used to build this model were somewhere above 76. So it's reasonable to make a prediction using 76. You wouldn't want to go too far above it, say 85. That would be extrapolation.